Hi guys, welcome back to the CCNA routing and switching video series. In this video, we're going to take the concepts that we have learned about VLANs and we're now going to apply them to a Cisco switch and look at how to configure this amazing feature known as VLANs. So before we dive in, let's look at the command structure that we're going to use or the commands we're going to use to configure VLANs. Firstly, we have to define our VLANs with the command VLAN number. This could be any number from 1 to 4094. There are some numbers which we can't use. Again, we'll have a look at that. Then we have to essentially assign our ports on our switch to individual VLANs. So like I said before, the way that a VLAN helps us segment our switch is that we define the VLAN and then we have to assign individual switch ports into that VLAN. Now, switch ports which connect to a single device like a laptop, computer, printer, and should be part of a single VLAN. We define those ports as access ports. So we would have to define those ports as access with the command switch port mode access. And then to assign that port to a single VLAN, we use the command switch port access VLAN number. And that's how we assign an individual port, which should only be in one VLAN, to a single VLAN. Next, we're going to have a look at configuring a trunk link. A trunk link carries traffic for multiple VLANs, and we would define a switch port interface as a trunk link with the command switch port mode trunk. And then we would define the native VLAN for that trunk link with the command switch port trunk native VLAN number. And then we can also do something called VLAN pruning. So with VLAN pruning, we define what VLANs are allowed over the trunk link, what VLANs are not. And we'll play around with that to see how that can affect end-to-end communication. And we do that with the command switch port trunk allowed VLAN, add, remove, accept, list, etc. All sorts of things. So the lab that we're going to work with is going to be a single switch. First, I'm going to define a VLAN 10 as the blue VLAN. And we're going to have two devices in VLAN 10 to ensure reachability. And then I'm going to take that second device, 10.1.1.20, and I'm going to assign that to VLAN 20. I'm not going to change the IP address just purely because I want to show you guys that even if a device has an IP address in the same IP subnet as you, if that device is in a different VLAN, we can't communicate because VLAN equals broadcast domain equals IP subnet. In reality, this second device should be part of a different IP subnet, but just for this purpose, I'm not going to do that, just to show you that even if they have the same IP address in the same IP subnet, they can't communicate. And then we're going to expand by introducing a second switch. That second switch will have a trunk link running to the first switch. We'll have a device on each switch. Again, we'll configure them to be part of VLAN 10, ensure communication. Then I'll show you how important it is to check to make sure that the VLAN list, so the list of VLANs allowed over a trunk link, matches on both sides to ensure end-to-end communication. So now I'm going to pause the video. The next time you see my screen, I'll be at the console line of switch 1. Welcome back, guys. So I'm now on the console line of switch 1. The first thing we're going to do is, to be fair, let's have a look at the VLANs which are already configured on the switch. So we'll do a show VLAN. This shows us all the VLANs configured on the switch at the moment. And as you can see, we have some default VLANs. So again, VLAN 1 is the default VLAN. Essentially, switches support VLANs by default. A switch has to come with a VLAN, and the default VLAN is VLAN 1. And as you can see, because that's our only active VLAN, all ports for the switch are going to be assigned to that VLAN, which means that all ports are part of the same broadcast domain on the switch. We do have these other VLANs, 1002, 1003, 1004, 1005, etc. These are essentially for older layer 2 technologies which are no longer supported. Those VLANs, we can't assign ports as the VLANs and we can't use the VLANs for anything else. So again, these are just default VLANs which are on every switch, and in this case, VLAN 1 is the only one which is used. VLAN 1002 to 1005, that's not used. The first thing we're going to do, let's create our VLAN. So we have to go to configure terminal, VLAN 10, give it the name of blue, and we'll define VLAN 20 now as well, give it the name of red. If I do a show VLAN brief, as you can see, VLAN 10 and 20 have been, VLAN 20 have been defined. Do show VLAN brief. Why didn't we? So let me try that again. So quit VLAN 20 name red. Why didn't that command go through? Do show VLAN brief. Or let me just do show VLAN. Yeah, okay, now it's there. Now VLAN 20 is there. For some reason, I created VLAN 20. Didn't accept it for some reason, which is a bit strange. Let's see, that worked now. Do show VLAN brief. And like I said before, we can use the do keyword to allow us to use these show commands in a global configuration mode or in a sub configuration mode. So that's very useful, and it makes us faster as well on the command lines. It's again do show VLAN brief. The VLANs are now defined. As you can see, we actually have no ports assigned to the VLANs at the moment. We have to do that. So now my laptop, the one that I'm working on, the one that I'm showing you this or recording this video on, that's connected to FA0/1. The other laptop is plugged into FA0/2. So now we're going to go to those interfaces, switch port mode access, switch port access VLAN 10. To verify, we can use the command show interfaces switch FA0/1 switch port. So again, this verifies some of the configuration. We can see administrative mode in this case is defined as a static access port. We can see access mode VLAN. In this case, this port is assigned to VLAN 10, and VLAN 10 has a name of blue. We can see whether it's in trunking mode, the native VLAN trunk, if this was the trunk port, the voice VLAN, which we'll cover in a later video, all sorts of good information. So this allows us to verify kind of the layer 2 configuration, operational mode, VLAN, the ports assigned to on the port. Now we're going to go into FA0/2, switch port mode access, switch port access VLAN 10. Let's verify that. Show interface FA0/1 switch port. Again, verify the same information. So static access mode, VLAN 10 has been assigned to all the good stuff. Show VLAN brief. So the difference between show VLAN and show VLAN shows us the same information as show VLAN brief. It shows us a bit more. If I do a show VLAN brief, this shows us essentially only kind of like the main information. So it just shows us the VLAN and the ports assigned to that VLAN. So as you can see, FA0/1 and 0/2 are now assigned to VLAN 10. Let me open up command prompt on my computer, CMD. Let's do a ping 10.1.1.20, and as you can see, I've confirmed reachability. Now, what I'm going to do, go back into global configuration mode under interface fast Ethernet 0/2, switch port access VLAN 20, Control Z, show interface FA0/2 switch port. As you can see, this is now part of VLAN 20, the red VLAN. Just to verify further, show VLAN brief, and as you can see, I am still plugged into VLAN 10. That device, the other device, is plugged into VLAN 20. Now we've got the same. So we both got an IP address, assigned in the same IP subnet. Can we communicate? And I think you guys already know the answer to this. But if I do a ping 10.1.1.20, as you can see, that isn't the case. So I can't communicate with the device, and we're in different. Because we're in different VLANs. So like I said before, the way the VLANs work, VLANs allow us to logically divide a single switch into multiple broadcast domains and multiple IP subnets by assigning ports to different VLANs. So essentially we're grouping ports together based on what VLAN they are in. And devices which are part of the same VLAN can communicate directly. In this case, if I wanted to communicate with a second laptop first of all, I would have to assign it an IP address and a different IP subnet. And then I would also have to involve a router to be able to route between those VLANs. So now, let's see, what can we do? So that's done. So that's all verified. That's verified. Oh yeah, I wanted to show you the MAC address table. So obviously, a switch has a MAC address table, which is just an address table filled with MAC addresses, and essentially tells the device based on the MAC address how to reach every single device around the network. If I do a show MAC address table, this allows us to verify it. And so as you can see, the way that the switch sorts or organizes the MAC address table is that it learns these entries dynamically. So by essentially hearing or receiving frames with a particular source MAC address. So in this case, the switch has received that ping. So that ping request that I sent, it was sourced obviously with my laptop's MAC address. And that port, that frame was received on interface FA0/1, so it's made a note of that. But what I wanted to point out here is the VLAN. So not only does the switch keep a track of the MAC addresses and what ports it stored the MAC addresses on, but it also keeps track of what VLAN those ports belong to. So in this case, when the switch goes to look through the MAC address table to forward that ping that I just sent, it's only going to look at the VLAN 10 entries. So it's going to look at the VLAN 10 entries and say, okay, do I see an entry for this destination MAC address in this MAC address table? No, I don't. So I'm just going to drop the packet because I can't really forward it anywhere. Or actually, it's going to flood the packet out of all interfaces in that VLAN, and it's still going to get a response back. So like I said before, we can have an IP address in the same IP subnet, but if we're in different VLANs, then we can't communicate. So that's fine. So now I'm going to introduce that second switch, which I've got. So if I do a show IP interface brief, at the moment that second switch is connected via FA0/8, so fast Ethernet 0/8. Now we're going to go under the interface, configure that switch port, mode, trunk. Okay, command rejected. Let's read that. So it says an interface whose trunk captures auto. Okay, so basically, some of the older switches, we have to configure what protocol we are going to use for tagging. So whether it's going to be ISL or DOM1Q. And obviously the industry standard is DOM1Q, so that's what we're going to use. So in this case, we use the command switchboard encapsulation, so switchboard trunk encapsulation, DOM1Q. So let's have a look at the options, DOM1Q. And then we can issue the command switchboard mode trunk. So now that port is now a trunk. If I do a show interfaces trunk, as you can see, it's listing that interface as a trunk, and you'll only see entries in this command if the interface which has been configured as a trunk is operating as a trunk, and B, if that interface is up. If the interface is down, it won't really show anything. It shows us the encapsulation, and also so reading these lists. So this shows us the VLANs which are currently allowed over this trunk link. So in this case, all VLANs are allowed over the trunk link because we haven't configured otherwise. This shows us the VLANs currently active on the switch. So in the case, VLANs 1, 10, and 20. This shows us the VLANs currently being forwarded over the trunk link. Now, STP can block which VLANs are being forwarded over a trunk link. STP, we will get to that later, but essentially what STP allows us to do. STP allows us to stop or essentially block redundant links in our topology, in our switch topology, to prevent loops. And again, we'll dive into that in a later video. If I enter that command again, it's saying that after the VLANs active on the switch, VLANs 1, 10, and 20 are currently being forwarded over the trunk link. So that means traffic for these VLANs can be forwarded over that trunk link. I'm also going to define a third VLAN called VLAN 30. Name of native. Now remember, the native VLAN should be an unused VLAN to stop double tagging. If I go under interface FA0/8, switch port, trunk, native, VLAN 30. Okay, that's fine. Like I said before, now I have to go over to switch 2 and configure the trunk port to match, because both sides of the trunk link have to have the same native VLAN to stop traffic coming in via one VLAN and leaving via another VLAN, which obviously could be or is a security issue. Okay, show interfaces FA0/8 switch port. As you can see, is configured for trunk operating as a trunk, DOM1Q encapsulation, native VLAN of 30. And one thing it doesn't show us, as you can see, it doesn't show us which VLANs, actually it does. So it shows the VLANs which are enabled over that trunk link. Brilliant. Well, some of the VLANs. So as you can see here, essentially trunking VLANs enabled, which is all, pruning VLANs enabled 2 to 1001, etc. All those sort of good stuff. So it shows a lot of information, as well as the show interfaces trunk command as well. Interfaces trunk. Okay, that's brilliant. So now what I'm going to do, I'm going to take my constant cable out, plug it into switch 2. Let's get that set up now. So let's go. Okay, so conf t interface FA0/8 switch port mode. So switch port trunk encapsulation. Sorry, DOM1Q. Again, this command you only have to enable on some of the older switches, because some older switches still support ISL and DOM1Q. Newer switches, they just support DOM1Q, so you could just configure this. So you can leave this command. Switch port mode trunk VLAN 30 name native. Interface FA0/8 switch port trunk native VLAN 30. Brilliant. Let's define our VLAN 10 name blue, VLAN 20 name red. Control Z, show VLAN brief. Okay, that's brilliant. So we've got those. Now I'm gonna just take out from that second switch, sorry, that first switch, plug into the first switch now. That's going to be, so now that second laptop is going to be plugged in to switch 2 port FA0/1. Go into that interface, sorry, conf T, interface FA0/1, switch port, mode access, switch port access VLAN 10. That's okay, so that's all good now. And now if I do a CMD, I should be able to ping that device now. Ping 10.1.1.20. Yes, so now I've confirmed reachability because we're both in the same VLAN. Now let's have a look at this trunk link further. Conf T, interface, FA0/8. This trunk link further. So let's have a look at VLAN pruning. So that's very important. So VLAN pruning. VLAN. So this allows us to control the traffic. So for which VLANs traffic is allowed to be carried for. So in this case, I could say this trunk link can support traffic for VLANs 10, 20, and 30. That means that it can carry traffic for those VLANs over the trunk link. By default, all VLANs are allowed over a trunk link. Let's say I were just to add VLAN 20. Let me issue that same ping command again. Ping 10.1.1.20. Okay. The ping stops. It's not successful. Okay, that's strange. Okay, so let me think. We're both in the same VLAN. Okay, brilliant. We both have IP address in the same IP subnet, so that should work. Not necessarily. So now if I do a do show interfaces trunk, as you can see, only VLANs 20 is allowed over the trunk. So what does that mean? That means only traffic for VLAN 20 is allowed to be forwarded over this trunk link. It's very important that the allowed VLAN list matches on both sides. So switch 1 and switch 2 should have the same allowed VLAN list. In this case, switch 2 from its end is not forwarding any traffic for VLAN 10 over the trunk link. So what's happening is my traffic is getting all the way to that second laptop. Okay, because from switch 1's point of view, it allows VLAN 10 traffic over the trunk link. Now that traffic going back is not being allowed because switch 2 doesn't allow traffic for VLAN 10 over this trunk link. So now let me add VLAN 10. So you would think it'd be simple as switch port trunk allowed VLAN 10. Okay. Now if I do show int trunk, wait a minute. Okay, where has 20 gone? So I had 20, I wanted to add 10. I entered the command. Why is 10 only there and 20 isn't? So let's break down this command. Switch port trunk allowed VLAN. So what this command essentially says, some of the keywords. When it says here word, this means that the list of VLAN IDs. So in this case, I could put 10, 20, all the VLANs which I want to be allowed over this trunk link, I can list. However, if I wanted to add a VLAN to the current list, I would use the add keyword. So in this case, add 20. If I do show int trunk, as you can see, VLAN 20 is now allowed over that trunk port. Let's go back to this command, switch port trunk allowed VLAN. So when it says here list, that means an absolute list. Okay, if we wanted to add a VLAN to the list after we've configured the list, we would use the add keyword. All obviously allows all VLANs, except says allow all VLANs except for the ones that I'm listing now. None allow no VLANs, and remove VLANs. So in this case, if I do v20 and do a command do show int trunk, as you can see, VLAN 20 is not allowed. If I was going to do switch port trunk allowed VLAN except, let's say put 10, 20, they have to be separated by a comma, and do a do show int trunk. As you can see, we get the same thing. So now all VLANs are allowed except for the ones that I listed in the command. So I'm going to put this back to switch port trunk allowed VLAN all. And now if I issue that ping command again, ping 10.1.1.20, give it a few seconds for the interface to come up. So STP is moving this trunk port through a listening and a learning state. We'll cover STP later on, but essentially it'll take 30 seconds before the interface can stop passing traffic. And again, we will talk about why. Let's go over some verification commands again. So as you can see, show VLAN allows us to list all the VLANs, and we can say, okay, to what port is assigned to what VLAN and what VLANs we have configured. show interfaces switch port. Shows us useful layer 2 information about that interface. In this case, its mode, if it's configured as an access port, what VLAN it's been assigned to, all the sort of good stuff. If I do a show, actually let me do this actually. Interface FA068, switch port, trunk, allowed VLAN. Let's put 10, 20, and 30. Control Z, show interface FA068 switch port. As you can see now, it's going to list allowed VLANs 10, 20, or 30. So again, show interfaces switch port is a very good command so we can verify all the layer 2 information for our individual interfaces. Show interfaces trunk just shows us our trunk ports and what VLANs are allowed to be forwarded over our trunk ports. And again, show MAC address table. That shows us our MAC address table, and as you can see, the multiple entries listed for fast Ethernet 0/8. The reason being is because from the MAC address table is from the local switch's perspective. It's which of its local interfaces does the switch use to reach that device. So what you may see is that where we have a trunk link, you will see multiple MAC addresses listed for the trunk link because the device from its local perspective can reach all the devices on that second switch or from that neighboring switch by going over that trunk link. And guys, that's all there is to it. So VLANs are that easy to configure. Literally configure the VLAN, assign the ports to it, and obviously trunk links between switches. And we've looked at how we can use the VLAN pruning to manually control which VLANs are allowed over a trunk link and why it's so important that the allowed VLAN list matches and why the native VLAN matches on both sides. If you have enjoyed this content, then please subscribe to my channel to see more content like this. If you have enjoyed this video and find it useful, then please share so that we can get high quality IT training to the masses free of charge. Thank you very much for watching.